Hi, let's take a look at a less common example of investigating elastic collisions. So, elastic collisions, like all collisions, always conserve momentum. Elastic collisions are special though because you also conserve kinetic energy of the objects. So, here we have two carts on a frictionless track, and the first has a mass of 340 grams and it's traveling to the right at 1.20 meters per second. The second cart is stationary. Now, we're told that that cart has an unknown mass, and after the collision, we don't know how fast that second cart is traveling, but we do know that cart 1 has to have the same mass, 340 grams, and it's traveling at 0.66 meters per second to the right. So, we could go to our default conservation of momentum, conservation of kinetic equation, and solve those two equations for our two unknowns, where we have mass 1 v1 initial is going to equal m1 v1 final plus m2 v2 final. And then we would have to say, well, 1/2 m1 v1 initial squared equals 1/2 m1 v1 final squared plus 1/2 m2 v2 final squared. We don't know m2, we don't know v2 final. And the algebra there is going to be a little bit messy. But in another video, when I talk about the concepts of elastic collisions, I said we could take those, solve those equations for the final velocities, and for the case where the second object is stopped, we can simplify those equations to say that the final velocity of object 1 is going to be m1 minus m2 divided by m1 plus m2 times the initial velocity of object 1. And the final velocity of object 2 is 2 times the mass of object 1 divided by the total mass times the initial velocity of object 1. So, we know the initial velocity of object 1, we know m1. Once we find m2, we can find the final velocity of object 2. And to find m2, we can take this first equation, because we have the final velocity of 1, we have the initial velocity of 1, and we have the mass of 1, so we could invert this to solve for the mass of 2. So if I take this and rewrite it without the fraction, I multiply both sides by the total mass, so I have m1 plus m2, quantity, times the final velocity of 1 equals m1 minus m2, quantity, times the initial velocity of object 1. So if I distribute out those speeds, I have m1 v1 final plus m2 v1 final equals m1 v1 initial minus m2 v1 initial. So I'm going to move my m2 terms to the left and my m1 terms to the right. So I subtract both sides by m1 v1 final, and I add m2 v1 initial to both sides. So I have m2 v1 final plus m2 v1 initial. Well, I could distribute out that m2 to say m2 times v1 final plus v1 initial as a quantity is going to equal m1 v1 initial minus m1 v1 final. I can distribute out in m1 to say that the right-hand side is m1 times the quantity v1 initial minus v1 final. So to solve for m2, I just divide by the sum of the initial and final velocity of object 1. So m2 is going to be m1, which is 340 grams, times v1 initial minus v1 final. So that's 1.20 meters per second minus 0.66 meters per second, which gives me 0.54 meters per second in the numerator, divided by v1 final plus v1 initial. If I add those two together, I get 1.86 meters per second. So I multiply 340 grams times my numerator divided by my denominator, and I get 9.87 grams. So the two significant digits, it rounds to 99 grams. Now, to calculate our final velocity of object 2, we would take 2 times the 340 grams we have, divide by 340 grams plus the 99 grams we just calculated, and then multiply by the 1.20 meter per second initial velocity of object 1, and that'll give us a final velocity of object 2 equal to 1.9 meters per second. Thanks for watching.